Hello, my sweet and precious children. Thank you for joining me. I'm excited to work with you on lesson 10 because we're talking more about fractions and improper numbers, and I love fractions. So for those of you following along at home, just a reminder, it's the Saxon 8-7 book. We are on lesson 10. That's on page 50. It is the second edition of this book, second edition. So just be careful about that because I think some of the problems are different. All right, so guys, so we are going to be talking today about writing numbers or doing division to find mixed numbers. You guys may remember when you were doing division before. For example, if you did 4 divided by 25, you would do 4 goes into 25 6 times. 6 times 4 is 24. Subtract, we get a 1 here. So you would do 6, remainder 1, right? We're gonna do the same thing, except instead of remainder 1, right here, what you do is you take your remainder and you put it here and you make it into a fraction over whatever this number is. So it's 6 1/4. 6 1/4, that's all you do. So no more remainders in division. You need to write it as a mixed number, okay? So taking a look at some of these other ones, like 100 divided by 3. 3 goes into 10 3 times, that gives us 9. We subtract 1, and when we subtract, we bring down. 3 goes into 10 3 times. 3, and then 3 times 3 is 9 minus 1, and we have a remainder of 1, but we don't write remainder of 1. We write 1 over whatever this number is, 3. So bam, that's all you got to do, okay? So a fraction, though, that is larger than 1. Let's talk about this. Let's say you have 3 halves. 3 halves. That means you have a pie and it is broken up into halves, and you've got 3 of these guys. Well, you notice there's only 2 there, right? So there's 1, 2, and then we got to have another one. So it's going to be like this. 3. So we have 1, 2, 3 broken up. What that really is this is one whole one, and then we have 1/2 of another. 1/2 of another. So 3 halves equals 1/2. I kind of talked about this in the last lesson a little bit, but we didn't get too far into it. Another way of looking at it is you say, how many times does 2 go into 3 without going over? 1 time. You always keep the same denominator, and then 2 times 1 is 2, plus 1 more gives us 3. So that's kind of another way of thinking about that. So let's look at some of these examples. Make sure you're writing these down in your notebook, guys. Go back if you need to. All right, so for A, this is number 2, or example number 2 for A. 5/3. 5/3. Again, we could draw it all out, but if we do that, it's going to be a pain. So what you ask yourself is, how many times does 3 go into 5 without going over? Now, it can't be twice because 3 times 2 is 6, right? And that would go over 5. So it's going to be 1 time, and then we always keep this denominator, okay? 3 times 1 is 3, plus 2 more will give us 5. So 3 times 1 is 3, plus 2 more gives us 5. All right, 3 2/3. Looking at B, 6/3. 6/3. How many times does 3 go into 6 without going over? 2 times, and without a remainder of anything. Another way of looking at this, let's go back, because I started this lesson with division. Do you see how it's on top of the table here? That means it goes under the table when we set it up like this. So how many times does 3 go into 5 without going over? 1 time. 1 times 3 is 2. So it's with a remainder of 2, but we don't write remainder anymore. We do 2 over whatever this number is, 3. So that's another way of how we get this, okay? Couple different ways to do that. All right, so let's look at example number 3. Let's rewrite 3 7/5. Okay, so let's look at example 3. I'm on page 52 if you wanted to follow along. 3 7/5. Guys, this is an improper fraction because it's greater than 1. When that numerator is larger, it is an improper fraction. So not only do we have a mixed number here, but we also have an improper fraction. So let's deal with just this guy first. 7/5. Again, if it's on top of the table, it's going to go under the table. So how many times does 5 go into 7 without going over? 1 time. And we do 1 times 5 is 5. 7 minus 5 gives us 2. So we have a remainder of 2. That means we have 2 over 5. So this garbage right here equals 1 2/5. 1 2/5. But we can't forget about this. So it's 3 plus, because remember when I said it at the beginning, 3 and 7/5, that and means addition. So now it's 3 and 1 2/5, 1 and 2/5. That means we can add these guys together. So let's make our lives easier. 4 and 2/5. 4 and 2/5. Good. So you always want to deal with the fractional part of it, turn it into a mixed number, and then add it to those whole numbers. I always say mixed numbers, improper fractions, I always mix those up when I say them, so I have to catch myself every time. All right, so looking now at, that was number 3. So for 4, the example 4, for A, we have 4/5 plus 4 more fifths, right? If we get that, we get 8/5. 8/5. How many times does 5 go into 8 without going over? 1 time with a remainder of 3, right? Because 5 minus 8 would be 3. For B, we have 5/2 times 3/4. 5/2 times 3/4. All right, so we multiply straight across the top, straight across the bottom, we get 15 over 8. How many times does 8 go into 15? 1 time, because if we did 2, it would be 16, right? 8 times 1 is 8, with a remainder of 7 will give us 15. Again, if you needed to do that over here, it's 15, 8. 8 goes into 15 1 time, and we get 15 minus 8, which gives us 7/8. 7/8, okay? Let's see about C here. 1 and 3/5. On this guy, I'm going to write it vertically because I think that's easier. All right, so we have 2 and 6/5. Oh, we got an improper fraction here we need to deal with. So we're going to set that 2 aside and deal with the improper fraction. And that is going to be 6 and 6/5 is 1, because how many times does 5 go into 6? 1 time with a remainder of 1. So we have 2, so that's just this guy, right? Just that guy. So that means we have 2 plus all that. 2 plus 1 and 1/5, which equals 3 and 1/5 would be your answer, your final answer. All right, so let's do example 5 now on page 53. Example 5. We have A is 3 and 1/3. Write each mixed number as an improper fraction. The way we do this is we take this times this plus this. 3 times 3 is 9, plus 1 is 10, and we put that over this denominator here. B, 2 and 3/4. Again, it's going to be a 4 for our denominator. This times this is 8, plus 3 is 11. 11. Yeah, I had to make sure. I'm always worried I'm going to make a tiny math error on these. All right, so 12 and a half. Again, it's going to be over 2, because that's our denominator. 2 times 12 is 24, plus 1 more is 25. So 25 halves. 25 halves. Good. All right, now would be a good time to pause the video and go ahead and practice those, do that practice section, A through L, on page 53. When you're done, come on back. All right. Okay, so for A, Alex cut a 35-inch ribbon. That's going to be 35-inch ribbon into 4 equal lengths. So 4 and 2, so divided by 4, right? So we're going to take 35 divided by 4, but the way we will write that is 4, and we got 35 here. How many times does 4 go into 35 without going over? If we do 7, how about 8? 9. 9 times 4 is 36, right? Oh, that goes over. Can't do that. 8. That's going to give us 32. 8 times 4 is 32. Minus, we get 3. We don't write the remainder 3. We say 8 and 3/4. So each piece is going to be 8 and 3/4 inch long, okay? For B, 1 day is what percent of 1 week? Remember, fractions are part over whole. Part over whole. So we have 1 day out of a whole week, which is 7. Now they want the percent of this, and unfortunately, that 7, do you remember in the last lesson where I was like, okay, if it's a multiple of 100, so if it's these guys here, 4 times 25 times, 4 times 25, let's try that again. 4 times 25, 5 times 20, 10 times 10. If it's one of these numbers, it's easy to convert it into a percent. But in this case, 7 does not fall on this list, so we do have to do some division here. We're going to do 1 is 1. Okay, so this is on top of the table, so it's going to go on the bottom. I just realized that they haven't shown you an example of how to do these. So this is going to be the first one. That's kind of weird because usually they give you at least an example at the beginning. So what we do is 7 does not go into 1. So we throw down a decimal here. We put a decimal. We're going to bring that decimal up. Okay. So 7 goes into 10 one time. 1 times 7 is with a remainder of 3. So this is going to be tricky. You know, and to be honest with you, I want you to skip this problem until we get to 2. There's going to be a couple lessons from now where it's going to make more sense. I don't want to introduce like a whole new thing here. So we're going to skip lesson B. Skip lesson. If I could rewind, I'm so sorry, you guys. I don't know how to do that on this, but okay. So for C, let's do that instead. 12/5. I do know how to pause though, so I'm going to do that really quick. All right, you guys. So for C, we got 12/5. If it's on top of the table, it goes under the table. So it's going to look like this. 5 goes into 12 2 times without going over. 2 times 5 is 10. We get 2, so we have a remainder of 2/5. So 12/5 becomes 2 2/5. Let's look at D. 12/6. 12 goes in, or 6 goes into 12 2 times with no remainder, so it's just flat out 2. Remember, this is just a division sign, so 12 divided by 6 is going to be 2. E. 2 and 12/7. So it's almost a mixed number, but we've got to fix this one fraction. So we're going to do that part first. How many times does 7 go into 12 without going over? So let's do some side work over here. 12, 7, that's going to be 1, that's 7. We get minus, so we're subtracting here, we get 5. So 1 5/7. So this is 2 plus 1 5/7. 2 plus 1 5/7. That gives us 3 5/7. 3 5/7 for E. Draw and shade circles to illustrate that 2 1/4 equals 9/4. So the way you would do that is 2 1/4. So all these need to be broken up into fourths, because that's ultimately what we're talking about. 2 1/4 is the same as 9/4. So your drawing should look something like this. I don't care if you use circles or squares, whatever, but just make sure they're broken up into 4s. 2 whole ones, that means 1, 2, 3. There's 1 whole. Here's another whole. And then we have 1/4. So 2 1/4. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9/4. So your drawing should look something like that. All right, guys, G is 2/3 plus 2/3 plus 2/3 equals 2, 4, 6/3. 6 divided by 3, because remember that's a division sign. That equals 2. H, we have 7/3 times 2/3. Guys, that's going to give us 14/3. How many times? And so let's do some side work over here. We'll do it up here so you can see 3 divided by 14. 3 goes into 14 4 times. 4 times 3 is 12. When we subtract, we get 2. So it's a remainder of 2/3. So this equals 4 2/3. 4 2/3. All right. Let me move my notes here. I accidentally covered up some of the next problems. All right. So let's look at I can't remember what I left off on. 1 2/3 plus 1 2/3. Again, it's written horizontally. I'm going to write it vertically. So 1 2/3. So we get 2 4/3 because 2 plus 2 gives us that 4, and then we just keep our denominator the same, right? So with this, again, I've got to deal with this fraction bit here, all right? So side work over here, 4, 3 goes into 4 one time with a remainder of 1, which is 1/3. So 2 plus 1 1/3 equals 3 1/3. 3 1/3. All right, that was I. Let's do J. Convert each of these into an improper fraction, 1 2/3. The way we do that again is 3 times 1 is 3 plus 2 is 5. 5/3. Okay. 3 5, 6. Again, 6 times 3 is 18 plus 5, which is 19, 20, and then plus 3 more is 23. 23 over 6. So let's look at L. L is 4 3/4. 4 3/4. 4 times 4 is 16 plus 17, 18, 19. That's for the 3, right? So 19 over 4. 19 over 4. All right, guys, I hope that makes sense and helps you out. If you have any questions, let me know. Otherwise, thank you so much.